For this demonstration, I would like each of you to transport yourselves to being employees of a new company called Acme Rideshare. Acme Rideshare's mission is to provide the best user experience in transporting people from point A to point B. So we've logged into the event portal, and the event portal is at the moment comprised of three main capabilities over here on the left. There's the designer, which we're kind of looking at right now, and that's your one-stop shop to create event-driven applications, events, schemas, and ultimately understand the way that all of them are interconnected. The catalog provides you the ability to browse what events are available, what topic schemes are being used, whether they're Solace or Kafka or MQTT, what have you. The different schemas that exist within the system that can be reused, whether they're Avro, JSON, XML, text, or binary, and the different applications that are formed as part of our Acme Rideshare organization. In addition, we have the discovery capability, which we're going to use a little bit later to actually do a complete discovery session on a Kafka cluster and understand what events and consumer groups and different schemas exist within that Kafka cluster and map them all in so that they're available within the catalog and the designer. So if we go back to the designer, let me explain what you're seeing here. So first of all, these octagons represent what we call application domains. And application domains are just a logical way to decompose our enterprise into bite-sized pieces. It could be by line of business, different teams, different related microservices, etc. And in this case, we have a consumer apps application domain, and that kind of acts as our more publicly exposed area that both the driver and the passenger app exist and exchange messages. Ride management is our logistical hub. It matches passengers that need rides with drivers that are in the area. And billing and payments is where, we do what it says. We do billing and payment type activity, but we don't know what's in there because we haven't yet done the discovery session to determine what that is. So we'll come back to that in a little while. So if we jump into the consumer apps application domain and understand what's going on within there, what we see is we have a passenger app and a driver app. And so these passengers and drivers are all emitting and receiving different events based off of, sort of the business moment that's being performed. So obviously passengers request rides, drivers need to be able to accept them, drivers update their status as they drive down the road, and ultimately passengers receive ride accepted events as well. In this case, if you're a user of the consumer apps, you don't necessarily need to understand what all is going on within ride management. You just need to know that these events are going in and out of a different application domain. In addition, a couple of events flow into the passenger app. In this case, the customer receipt generated and the driver funds deposited is received by the driver app sort of at the end of each journey. But note that these aren't connected to anything, and that's going to be part of our discovery session of what is really going on within billing and payments application domain. Next, if we drill into ride management, you can see that we're making use of some different connectors. The reason for this is our consumer apps are actually using MQTT as the wireline protocol, since it's a very popular IoT communication mechanism, and those passenger and driver apps are actually mobile devices. These different connectors actually transform from taking data out of the Solace event broker that's using MQTT and making them available within the driver management for the driver management application in the Kafka cluster it's connected to. And so in this case, that ride requested event actually now gets transformed to having a Kafka topic as well as a different schema, in this case, an Avro schema. In this case, it's also owned by a different person. It's owned by Heinz. The last thing I want to call out is, you see here that, these pictures can obviously get very, very busy. And so one of the key capabilities we provide is the ability to apply tags. And tags could, for instance, be based off of a use case name. So let's say at Acme Rideshare, we have a use case called request ride. Well, maybe you just want to see what are the events and applications that participate within that use case. Well, we can now have a filter and highlight it as only the applications and events that are actually participating as part of that use case. Finally, just like in the consumer apps, there's this event that looks like it's being produced by driver management and is actually not being consumed by anyone. Turns out it is being consumed by the billing and payments application domain, and we'll discover that relationship in a few minutes. But before we do that discovery session, let's dive into one of these events and understand what kind of metadata are we really storing about each event. So if we go into ride requested as a great example, we can come up here, view details of that actual event. And from here, what you'll see is the sort of the common metadata that we're storing about each event. So first of all, what topic? So this is using MQTT. So it's using the / delimiter. Who was it created by and changed by? What's the JSON schema being used? In this case, it's using the ride request JSON schema, which has things like product ID, start latitude and longitude, end latitude and longitude, a description. So the description we feel like is really, really an important field in order to let users really understand what is the business moment related to this event. In this case, it's fired when a customer is confirmed that they wanted a ride. In addition, from an audit trail perspective, creation time last modified, and ultimately what applications are subscribing and publishing. In this case, it's really simple. The passenger app produces this event, and the Solace source connector is who receives this event. You can also see full revision history of how this has changed. There's been 2 revisions, both revisions done by myself. You can restore it. You can do some easy sort of comparisons around what's changed, so that you always sort of know really what's the lineage of the event and how has it evolved and changed over time. Okay, so now that you understand sort of the data that we're storing around an event, let's go back to the designer and deal with this billing and payments black hole that we currently have. We have no visibility into what billing and payments does, how it interacts with the other application domains, and we want to fix that. So remember, billing and payments is a Confluent platform deployment of Kafka. And so one of the things that we've been working really hard at Solace to do is develop runtime discovery agents that can go out and scan a variety of different event brokers, pull in the metadata, and ultimately help populate the catalog and the designer of the event portal, so that number one, you have an authoritative source of truth around what's really going on within the runtime, and number two, keep you from having to manually enter the designs into this tool. So the discovery agents are available as either a runnable jar file or a Docker container. And once you have it installed and you bring it up, you ultimately will have a choice of broker types to perform a runtime discovery scan on. In this case, we're going to choose Confluent Kafka. We're going to enter the connectivity information for our broker. In this case, we're not being very secure. You can also optionally add, connector authentication, schema registry information if you're using Confluent Schema Registry, and scan basically based on topic or for all topics. So in this case, we're just going to scan our entire billing and payments Kafka cluster and see what the results are. So after a little while of that scanning, sort of enough time to give it access to as much data as possible, we can stop the scan and download the results. Now that we've downloaded the scan file, we can navigate to the Discovery tab and upload the scan file into the event portal. So ultimately we navigate, find the scan that we had. So in this case, it would be this JSON file, and ultimately click open. So we've now uploaded that scan file into the event portal, and it shows up in the list of scans that we're able to stage for import. Stage for import is really the idea that we've discovered a lot of different things. In fact, we can kind of pull up this list of, we found 3 consumer groups, and we found some different connectors, one being the Confluent replicator, which is providing data in from driver management, a sync connector providing information back to the MQTT domain that the passenger and driver apps live in, 5 topics, and 5 Avro schemas. So all of this was discovered. And then what staging really allows us to do is map that into the constructs that we use within the event portal. We need to map in who publishes what, how does it relate to applications. And the first thing that we need to do is we need to create a domain for which these elements are all going to be mapped to. So in this case, the domain is going to be called billing and payments. And what we'll do is we'll just basically pull in the different connectors into that and these events into billing and payments, because really everything related to our scan was the cluster that billing and payments owns. So from there, we can go into the billing and payments application domain here within staging, and we can continue to do some additional mapping. So for instance, I mentioned before that there's two applications. One application is called billing app, and another application is called payment processing or payment processor. So now we've created those applications, we need to map the consumer groups into those applications. So in this case, the trip update goes to the billing app. The payment processor consumer group goes into payment processor, and this payments goes into the billing app as well because of the billing group. So we basically now map that to application constructs. And then the other thing that we need to do is we need to find who's publishing some of these different events. So for instance, the receipt created is created by the billing application. The payment request comes from the billing application as well. The payment process, that comes from the payment processor upon a completed payment. And funds deposited also comes from the payment processor. So if we were to look at this more from a complete flow perspective, we have a Confluent replicator that's replicating that trip updated data out of the driver management application that's being consumed by the billing application. The billing application basically sends a request event over to a payment processor. The payment processor deposits the funds into a driver's account and sends an event for that. And when it's done, it says back to the billing app, hey, I'm done with depositing that. The payment's been processed, and the billing app then is able to produce a receipt event. And both the funds deposited and receipt go into that sync connector to be available in the MQTT domain. So we basically completely mapped now based off of the things that we discovered, the billing and payments application domain. So the last step here that we do is we commit it to the event portal that imports it into both the designer and the catalog so that it can now be visualized and used by others within the event portal. Okay, so great. The information that we just imported into the event portal is now available within the designer. In this case, you're brought to the billing and payments application domain view, where it's all nicely organized as to how the different events are providing relationships and flow between these different applications that we defined in the previous step. Maybe the next thing that we should do is really deal with the fact that most of the users of our Acme Rideshare company and apps, that their number one complaint is that they're sick and tired of having to manually input receipts into expense reporting systems. And what we're finding is that SAP Concur is the most commonly used expense system. So what we could do is create a new application called, in this case, expense reporting integration application. We can provide a description like this app will integrate receipts into SAP Concur. As an example, the application class that we're using here within this application domain is Kafka, so it's going to be a Kafka application. We can assign Mark D. Pasquale as an owner of that application, and we can assign tags. In this case, we're using tags to represent use cases. So in this case, receipt is a use case that we're keeping track of, and then we can manage and associate the event. So in this case, we want to subscribe to customer receipt generated. And once we click save, now that's available on the palette, and what we're able to do is we're able to export an async API specification of that and download the spec so we can generate code. Okay, so that file has now been downloaded, so we can now navigate to a command line terminal where I already have pre-typed, because I'm sure you don't want to watch me do that, the command for the async API generator to create a project called expense reporting application using the Kafka binder. All the different sort of Maven and Java package information, how we're going to connect up, username, password, and what we're going to use is the Java Spring Cloud Stream template in order to actually generate our code. So now ultimately that code generator ran and it created that project called expense reporting integration. So from there, what we can do is we can pop open on IntelliJ, and IntelliJ is able to look into that folder and recognizes that it's a Maven project, complete with using the Kafka binder. We can click into source, specifically into the application that was generated, and it basically says that, hey, here's a function called onReceiptGenerated, and it's going to consume a customer receipt JSON event, and we're going to add our business logic here in order to really integrate with SAP Concur. So hopefully that shows a little bit around how async API is integrated into the event portal, which allows a developer to have a much better experience with building event-driven applications. Last thing I really kind of wanted to show that I forgot to during the session where we imported this was, what we're able to also do is, for the things that we discover is really find interesting metadata in configuration. So in this case, the Confluent replicator had this configuration that we discovered, and we're able to keep track of that now, under the description part of the metadata involving these different source and sync connectors, consumer groups. So kind of anything that we're able to discover, we can automatically add that into the description so that you have a lot better awareness around how things are actually configured within the event portal. So, let's say that now you're off and running with your expense report integration application. It's running, and what the next step is we could run another discovery scan, which I've already done, in order to determine, is everything now within the billing and payments application domain, is that all really meeting this design, or are there actually any discrepancies that are different from a runtime perspective? So after starting up the newly created expense reporting application, we did a discovery scan on the Kafka cluster, and it's 86% in sync with what we were expecting. And so what ultimately we found that's interesting is now there's a billing, payments, receipt gen expense group, and it's subscribing to not the event that we would have thought. It should have actually been consuming the receipt created, that's being used over here. And in fact, what we notice is I fat fingered and didn't use good spelling here. It's I before C except after C, which is actually something I frequently somehow misspell. And so what we can actually do is we can go here into topics. Highlighted here is that this is sort of the problematic event. We can click on it, and what we can actually do is click the report button. It'll actually tell us that and auto-generate a message to Mark D. Pasquale saying that there's a discrepancy for this topic. We determined through a baseline comparison that these topic names don't match for that application, and we can go ahead and send that off to Mark, who is the owner of the application in that consumer group. So hopefully that shows you really the massive amount of power that the event portal provides, both from the ability to design new applications, to discover things that you already have within your Kafka cluster that now you want to manage and govern within the event portal, and even do and perform audits related to how is the design drifted as it relates to runtime. So thanks for checking it out, and I'll turn it back to myself. Thanks.